Okay, today we can see how to partition an integer. That is, this is integer. So we have to write this integer as sum of positive integers. What we have to do is, this n must be written as sum of positive integers. For example, if you take 5, what we can do, we can write 5 as a partition, because so this is a positive number. Otherwise, what we can do, we can write that as 4 plus 1. So sum of two positive numbers, or we can write that as 3 plus 2. Okay, so similarly we can write this as 3 plus 1 plus 1. Otherwise we can write 2 plus 2 plus 1. Then we can write 2 plus 1 plus 1 plus 1. Or we can write 1 plus 1 plus 1 plus 1 plus 1. So these are the different ways the integer 5 can be partitioned. How many ways here? There are 7 ways. Okay, so if the integer value is 5, there are 7 different ways we can partition that. Therefore, our problem is, given an integer n, we have to find how many ways that particular n can be partitioned, and then we can write as p of n. So our problem is, we have to find the value of p of n for a particular n. Now, what we can see is how we generate this particular sequence of partitions. So there is a procedure for that. What we have to do is, suppose we can write that as 4. Okay. Now, if our input sequence, that is A1, A2, etc., some AK. So this is the sequence. We have to find its successor. For example, if you take this as that particular sequence, we have to find the successor. This is the successor of that particular value. Okay, how to find the successor? That is, we have to find the largest index. Okay, largest index I, such that this A8 not equal to 1. Okay, so maybe we can assume that some A8 is here, so that value is not equal to 1, and all the remaining here are 1. Okay, so that's it. The largest index I such that A not equal to 1, and also we can take that A equal to sum A plus 1. If we assume this, then what we can do is, this number can be, the successor of this number will be, we can write A1, A2, etc., I minus 1. So those things are not going to be changed, but the suffix that is starting with A, the suffix will be replaced by A, some number of A, then a particular R, but this R is less than A. Okay, so we have to write A. How many times it is possible? Final thing is R. Now once again, if you sum all these values, it cannot, it should be n. Okay, suppose this is a partition corresponding to n, then this sum should also be n. Now we see this example, how we get that. Suppose you take 4 plus 1. So largest index in which that is not equal to 1 is this particular 4. But 4 can be written as 3 plus 1. So we can write 3. Then if you write 3, then what happened? 3 plus 3, 6. But what we need to do? So sum should be 5. So we cannot write 3. So first 3 we are writing, then the balance that 2. This 2 is less than 3. Okay? So this R is less than A. Like that. Now if you take this particular sequence, its successor is, this is the largest index for which that value is not equal to 1. So now this 2 is equal to 1 plus 1. So we can write 1 plus 1, like that. Okay. Now if you take this sequence, this is the place where the value, the largest index where that value is not equal to 1. So now 3 equal to 2 plus 1. So we write 2, then again 2. So 2 plus 2, 4. If you write 2 again, that is 6. But it should be 5. Okay. So 2 plus 1. Okay. That is the way we can generate all these numbers. Okay. Now our problem is not to find these partitions, but we have to find the value of P of n. That is, number of ways the particular number can be partitioned. For that, we can see number theoretic approach. First, we start with a particular number. We can put one dot here, then one dot, then next row two dots. Then what we can do? One dot, then two dots, then third row three dots. Okay. Similarly, one dot, two dots, three dots, and fourth row four dots. Okay. Now what happens? How many dots are here? One dot. Here how many dots? Three dots. 1 plus 2. Three dots are there. Here 1 plus 2 plus 3. So that means 6 dots are there. Here 10 dots are there, and so on. Okay, we get a number system. Okay, some kinds of number, some kind of numbers we are getting. Now what happened? If you take the boundary of these pictures, then what happens? You can connect these points, and that becomes a triangle. Now if you take this one, if you connect the outer dots, you get a triangle. Now here also the same thing. If you connect, you get a triangle. Okay. So these numbers are called triangle numbers, and that can be written as Tn. Okay. So these are all triangle numbers. Now similarly, we can see another set of numbers. We can start with the one dot, then two dots in two rows, then three dots in three rows, then four dots in four different rows, like this. Okay. Now if you count the number of dots, here only one dot, here 4 dots there, here 9 dots there, here 16 dots, and so on. Now if you connect the dots in the outer boundary, you get a square. So here also if you connect, what you get? You get a square. And once again if you see, here also you get a square. So these numbers are called square numbers. We know that square of 1 is 1, square of 2 is 4, square of 3 is 9, like that. Okay. So that square term came like that. Okay. Now these numbers are called square numbers that can be represented as SI. So we have two kinds of numbers. So one is triangle numbers, and the other one is called square numbers. Okay. Now we can see the relationship between these two. First of all, let us take this triangle number. If you say Tn, that is the value of Tn will be, maybe if you take T3, so this is actually T3. How we get T3? 1 plus 2 plus 3. Okay, here 1 plus 2 plus 3 plus 4, like that. So Tn is equal to, that is 1 plus 2 plus etc. plus n, that is equal to n into n plus 1 divided by 2. How we get that? For example, if you take T99, so T99 is actually 1 plus 2 plus etc. plus 99. So we are adding all that. Now what you can do is, suppose you add 99 here, and if you add 98 here, etc., and here if you add 1, then what happens is, okay, we take only this particular factor. We have to find only this, but we take this particular factor. Now 1 plus 99 100, right? And 2 plus 98 again 100, like that. Here this is also 100. Now how many times 100 there? 99 times 100 there. So 99 into 100, then 2 times we have done, but we want only this. So that means by 2. So that is our T99. So T99, that is written like that. So that is n into n plus 1 divided by 2. Now what we can do is, we can find the relationship between the triangle numbers and the square numbers. Okay, first we can take a triangle number. We can take like that T3. So 3 dots. Then okay, we can represent that by a circle. 3 circles, then 2 circles, then 1 circle. Now another T3 we can take. So that is 1 dot, then 2 dots, then 3 dots. Now what we get? We get something like a rectangle. Now what happens? You can take the last row of both the numbers. So here 3 dots, here 3 circles there. Now you can remove this one particular row. Then if you combine, then what you get? 3 circles here, then 2 circles, then 1 circle, here 1 dot, then 2 dot. Now it forms a square number, okay, that is S3. This is actually S3. So 2 T3s we added and 3 values we removed. So in general, the last row we are going to remove. So if you take Tn, the n numbers will be removed. So Sn can be written as 2 times the triangle number Tn minus the n values, that the n dots, that is in the last row that we are removing. So 2Tn minus n. Okay, how we get this value again? This Tn is equal to, already we have determined Tn, that is n into n plus 1 divided by 2, then minus n. Now what you get? You get n square plus n minus n, that is equal to n square. So we are getting the square number. Okay, now using this logic, what we can do is, first we can take a dot, and if you draw 2 lines like this, okay, we can take 2 lines like that, and we can put the dot corresponding to the triangle numbers. So 1 dot here, then 2 dots, then 3 dots, then 4 dots, like that. So this is the triangle number. Okay, that represents the triangle number. Now we can take one more line, then here also we can make a triangle number. So 1 dot, 2 dot, already 1 dot is there, okay, 2 dot. So that means we are avoiding the repetition, okay. So that the repetition only one time we have considered. Okay, now 3 dots, then 4 dots, like that. So 2 triangle numbers we have taken. Now that forms a square, right? So now you see, if you connect this, one side, second side, that is first side, second side, third side, and fourth side. So that forms a square. Again, if you take that, side 1, 2, 3, and 4. So that forms a square number. Now we can make one more line. And here also we consider triangle number. So okay, 1 dot, then 2 dot, then 3 dot, then 4 dots, and so on. Now what happens if you take this side number 1, then 2, 3, 4, 5. So that forms a pentagon. Okay, that forms a pentagon. And here also 1, 2, 3, 4, 5. So this forms a pentagon numbers. Okay, so we get a new number, pentagon number, that we call as Pi. That we call as Pi. Now we find the value of Pi. Okay, first only 1 dot. So first number is 1. Then second 1 plus 4. So 5. Then 5 plus, here you see 3 plus 2 plus 2. So that means 7. So 5 plus 7, that is 12. Then here another 10 we are adding, that is 22, and so on. So this is what our pentagon numbers. But some of the numbers are missing here in the general pentagon numbers. Okay, this is called as a pentagon numbers, and we need general pentagon numbers. In that, some numbers are missing. What the numbers that are missed from here? That is, here 2 is missing, then here 7 is missing, then 15 is missing, then here 26 is missing, and so on. That is, between every 2 numbers, one particular number is missing. How we find these numbers? That is 1 plus 1 2, then 5 plus 2 7, 12 plus 3 15, 32 plus 4 26, like that. Every time we increment by them. Okay, added by 1, added by 2, added by 3, added by 4, and so on. Okay, now 1, 2, 5, 7, 12, 15, 22, 26, etc. That we call as the general pentagon numbers. Now we are making use of these general pentagon numbers to find the value of P of n. Okay, that is number of different ways a given particular number that can be partitioned. Okay, how we get that is, this is based on a formula. That formula is we take P of n. Before that we take some smaller values. For number of ways it can be partitioned. If you take n, this is the value for P of n. Okay, if you take 1, only value 1 can be partitioned in only one way. Suppose you take, there are 2 ways. You can try 2 or 1 plus 1. Okay, 2 different ways. So it is 2. Then if you take 3 ways. Then if you take 5, there are 7 ways. Then if you take 5 4 is missing. If you take 4 5 times, then if you take 5 7 times, if you take 6 9 times, then if you take 6 11 times, 6 11 times, and 7 15 times, and so on. So these are some of the values for the smaller numbers. That is number of different ways it can be partitioned. Now the question is, if you give 0, then that can be considered as a special case. Now we do not know the value, so we have to find the value. After stating the formula, we can get the value. Now the formula is, now we are using the general pentagon numbers. Once again we can write the general pentagon numbers, that is 1, 2, then next number is 5, then 7, then 12, 15, then 22, 26, and so on. So that's the general pentagon numbers. Now Pn minus Pn minus 1, that is this one, then minus Pn minus 2, so this one, then next to plus Pn minus 5 plus Pn minus 7, n minus 7, then minus, that is these two numbers having negative sign, these two having plus sign, next to minus, next to plus, like that it goes on. Okay, now next pentagon number is 12, so Pn minus 12, then Pn minus 15, then plus, and Pn minus 22, and so on. So this is what the formula. Now what this says is, if you sum all these values, then that becomes 0. But what happens is, suppose we say n is equal to 5. So P of 5 here, okay. So if you take n is equal to 5, n minus 7 is equal to minus 2. So that will be the negative number. So many places we get negative values. We assume that P of any negative number that is equal to 0. That we assume. Therefore this cannot go as an infinite sequence. So whenever we get a negative number, then remaining numbers will be negative numbers, and hence those numbers can be replaced by 0. So we get a term which is not infinite, and that can be mapped to 0, and hence we can find the value of P of n. Okay, now the question is, what is the value of P of 0? Okay, that's a special case. For that, you can put n is equal to 1. Okay, you can put n is equal to 1 in this case. So if you put n is equal to 1, what happens? It is P of 1 minus P of 1 minus 1, that is P of 0, and all the remaining numbers are negative numbers, that are all 0 based on this. Then finally that will be equal to 0. But we know P of 1 equal to 1, that is 1 minus P of 0, that is equal to 0. That implies P of 0, that is equal to 1. So that means the partial value, that is P of 0, that is also 1. Now based on that, we can find the values for some number. Maybe we can take 7 here. Okay, we can take 7. Actually we know the value 50. So if you want to find the P of 7 up to 6, okay, we supposed to know the value, right? Then only we can substitute those values to get that. So P of 7, okay, we can take P of 7. Now based on this formula, P of 7 minus P of 7 minus 1, that is P6 minus P5, because n minus 2, okay, 7 minus 2, 5, then plus this is 2, P of 2, then this is 7 minus 7, that is 0, P of 0, and the remaining numbers will be negative, okay, P of negative value, so that and all will be 0, so this is equal to 0. Now we do not know the value of P7, we have to find that, but we know the previous values. What is the value of P6? That is 11, okay, so minus 11, then P of 5, that is 7, then P of 2, that is 2, then P of 0, 1, that is equal to 0. Now that is, that implies P of 7, now minus 18 plus 3, that means minus 15 equal to 0. So that implies P of 7 is equal to 15. So that we got that, okay. Thank you.